So Tuesday we started 4.1, correct? We talked about the degree of polynomial functions, leading coefficient, standard form, and describing the end behavior of our polynomial functions, correct? Everyone remember that from Tuesday. Today we're actually going to get into graphing the polynomial functions. So we're going to be graphing today. Yay, graphing's our favorite. So let's just hop right in. Graphing polynomial functions. So to graph a polynomial function, first plot points to determine the shape of the graph's middle portion. We're going to get that middle part of our graph first, and we'll go from there. Then connect the points with a smooth, continuous curve, and use what you know about end behavior to sketch the graph. Do you guys remember that chart from yesterday where it was either even or odd degree, and the leading coefficient was positive or negative, and it told us what the end behavior was? We're going to be using that today as well. Okay? How do you think we're going to get our points to get the middle portion of our graph?
Degree and leading coefficient.
Not quite. So it's one method of graphing that we used quite a bit when we graphed parabolas. We're going to use a table of values, where you pick some x values to plug them in, get your y values, and that'll give us some ordered pairs. Does that make sense? So we're going to be making some tables of values today, which with a calculator that should be pretty easy. Plot our points, connect it with a smooth continuous curve, use our knowledge about end behavior to finish sketching the graph. Any questions so far? Before we jump into some examples.
Do we need to get a calculator now?
Yeah, if you don't have a calculator, go ahead and grab one. Okay, if I move on to the examples. So it wants us to graph f of x equals negative x to the third plus x squared plus 3x minus 3. Negative x cubed plus x squared plus 3x minus 3. Just on letter A. What was the first step it told me to do? On the previous one.
Determine the shape of the graph's middle portion.
So I got to plot some points. How am I getting those points again? Create a table of values. So for today's purposes, we're going to use the same numbers for our x values. That way you're not sitting there trying to think which x values to use. Today we're just going to use negative 2, negative 1, 0, 1, and 2. Use those on all your problems that you're graphing. Okay? So I'm just plugging these x values in to my original function. Whatever I get when I plug it in, that's my f of x or my y value. So I'm doing f of negative 2, just replacing all the x's with negative 2. And be careful when you're typing this in your calculator, make sure you're using parentheses. Type it in exactly like I'm writing it on the board. Use the same exact parentheses, signs, symbols, all that good stuff. I'm going to go ahead and do it by hand while some of you may be typing it in the calculator. What would negative 2 to the third power be? Negative 2 times negative 2 times negative 2. Negative 8. Negative 2 squared. Positive 4. 3 times negative 2. 3 times negative 2?
Negative 6.
Negative 6, and then I still have that minus 3. On your negative 8, don't forget there's still that negative sign in front of it. So I have negative, negative 8. What's that going to turn into? Positive 8. So I have 8 plus 4 minus 6 minus 3. What's 8 plus 4? 12 minus 6. 6 minus 3. So when I plug negative 2 into my function, my y value, my f of x value that spits back out is 3. So my first ordered pair that I'm plotting is negative 2, comma 3. Everyone good with that? Once again, you can type this in your calculator. Just make sure you type it in exactly like this with all the correct parentheses and signs. If you type it in just like that, it should pop out 3 by skipping all these steps. Everyone got it? Now let's plug in negative 1. That'd be negative, negative 1 cubed plus negative 1 squared plus 3 times negative 1. Is everyone okay if I kind of go through this a little quicker? We all okay plugging in and working it down? So that's going to give me a positive 1 there, plus 1, minus 3, minus 3. That'll give me 2, minus 3, minus 3. Negative 1 minus 3, which equals negative 4. Everyone okay with that? Any questions about any of my steps? Now, 0 is always really nice to plug in, because anywhere I have an x in any of my terms, what are those going to be when I plug in 0? 0. So I got 0 plus 0 plus 0 minus 3. Negative 3.
Don't even have to do anything.
Nope. Nope. It's always nice plugging in 0. Plugging in positive 1. Get negative 1 cubed plus 1 squared plus 3 times 1 minus 3. It's going to give me negative 1 plus 1 plus 3 minus 3.
0.
That'll be 0 plus 3 minus 3, which turns out to be 0. Everyone good with that? And finally, plugging in f of 2. That'll give me negative 8 up front, plus 4, plus 6 minus 3. Negative 4 plus 6 minus 3. 2 minus 3, which is negative 1. Everyone good with that? Like I said, you should get quicker doing that, plugging it in your calculator. Make sure you use the correct parentheses, though. Use parentheses when you plug in. Okay? So this table of values gave me a bunch of ordered pairs. Negative 2, comma 3, negative 1, comma negative 4, 0, negative 3, 1, 0, 2, negative 1. What I'm going to do now is I'm going to plot those points on my graph. I will give you graph paper today, so don't worry. But if you just want to look up here for the notes purposes, or if you want to try to sketch it on your notes, that's fine. But I'm going to go ahead and graph these. My first ordered pair is negative 2, comma 3. That's going to be left 2. Excuse me. Up 3. Is everyone okay plotting ordered pairs on an XY coordinate grid? Negative 1, comma negative 4. Left 1, down 4. So that'd be right there. 0, negative 3. That'll just be down 3 on my y-axis. 1, 0. That'd be right 1 on my x-axis. 2, negative 1. Be right 2, down 1. Right there.
Do you have to connect them?
Say what?
Do you have to connect them or no?
Yes, we're getting there. So we can kind of see the shape of my graph kind of starting to form a little bit. Okay? What was the next step on that first slide that we saw?
Connect the points with a smooth continuous curve and use what you know about the end behavior to sketch the graph.
So let's think about the end behavior real quick before we draw or we connect our points. Okay? What's the degree of my polynomial function here? Cubic, so what's the degree? 3. Is that even or odd? It's odd. What's my leading coefficient here? -1, so that's negative. So remember that handy dandy chart we had yesterday? We go find the box that says odd and negative. That'd be this upper right box. So whenever I'm graphing this, I need to make sure as my graph is going to the left, it's going up to positive infinity. It's going up to the left. As my graph is going to the right, as my x values are getting bigger towards positive infinity, my y values are going down towards negative infinity. So I need to make sure I account for that whenever I'm drawing my graph. Okay? So up to the left, down to the right. When I was in high school, I had a geometry teacher. He called them disco functions. Because they're like this. Always helped me remember it. So there you go. That works. So I know it's going up to the left, correct? So I'm going to just keep my graph going up to the left. Then I'm going to go through and connect my points using smooth, continuous curves. And I know it's going down to the right, correct? Now, is your graph going to be perfect? No. If you wanted to make it perfect, you'd start needing to plug in decimals and fractions. I'm not going to make you do that. We're just kind of drawing sketches of our curves, basic ideas of what they are. Does that make sense? So it doesn't have to be exactly perfect, but it needs to be somewhat similar to what this would look like. Okay? Questions on letter A? Can I erase and move to letter B? I should have kept that table of values. Oh well, too late. Okay, letter B. X to the fourth minus x to the third minus 4x squared plus 4. Once again, creating my table of values. Like I said, we're just going to use the same x values. -2, -1, 0, 1, 2. For time's sake, I'm going to have some of y'all plug these in for me. So does someone want to volunteer to plug in -2? Does someone besides Mallory want to plug in -1? I'll do 0. Who wants to plug in 1 for me? Jordan. And raise your hand if you want to do 2. All right. So go ahead and type those in for me. Tell me what you're getting. For 0, I'm getting 4. Golly, y'all are so slow. Hurry up. Jeez. Say what?
I got -4.
Oh, you already had it, didn't you? So we got -4 for 2. Whenever, if you're someone who's plugging it in for me, raise your hand and let me know.
I got 2 for -1.
2 for -1. What else are we getting? You okay, Jordan?
I don't think so.
What'd you get?
I think I got 8 for -2.
Not,
Is that wrong?
not quite. What'd you get? It is 12. And what are we getting for 1? So I'd get, yep, 0. Do I need to go through any of those, or are we all okay plugging in values? Like I said, if you're just typing in your calculator, be careful, be careful, be careful with your parentheses and your signs. Okay? So here's our ordered pairs. We're going to go ahead and plot those on our graph. So negative 2, comma 12. Negative 2, 12 is somewhere up here off my graph, right? So I'm just going to put that point there. I know that's not quite negative 2, 12. I'm going to put it up there so I don't forget about it though. Okay? I just need to know the general direction that negative 2, 12 is. Negative 1, comma 2. Left 1, up 2. There it is right there. 0, 4. Oops. 0, 4, that's just up 4 on my y-axis. 1, 0, that's to the right. 1 on my x-axis. 2, negative 4, that's right 2, down 4. So there's all my plotted ordered pairs, correct? I need to look at the end behavior of my graph. So, my polynomial function. What is the degree in this case? 4, which is even or odd? Even. What's my leading coefficient? Positive 1, right? So it's positive. So I'm looking for the even positive box. That'd be this lower left one. So as my x values are getting smaller, going to negative infinity, my y values are doing what? Going up to positive infinity. So to the left it's going up. As my x values are going to positive infinity, what are my y values doing? They're going up to positive infinity as well. So my graph needs to be going up to the left, up to the right. Bless you. Does everyone see that? So let's go back to my graph, connect our points. I'm going to go ahead and erase this point up here, because I haven't forgotten about it. But my graph is going to be going up towards negative 2, 12. And now I'm just going to connect all my points with a smooth, continuous curve. Now I need to make sure it's going up to the left and up to the right. Does everyone see that? Any questions on this example B? Everyone good there? Can I go ahead and move on? Is that all it asked for on the directions? Yep, just a graph. Oops. Last example for 4.1 says sketch a graph of the polynomial function f having these following characteristics. F is increasing when x is less than 0 and x is greater than 4. F is decreasing when x is between 0 and 4. F of x is greater than 0 when negative 2 is less than x is less than 3 and x is greater than 5. F of x is less than 0 when x is less than negative 2 and x is between 3 and 5. After I sketch my graph from those characteristics, and then it wants me to use my graph to describe the degree and leading coefficient of f. So I'm going to go ahead and write these characteristics over here on the whiteboard. So I have them down so I can look at them whenever I'm looking at our graph. So our first one, f is increasing when x is less than 0 and x is greater than 4. Second characteristic, f is decreasing when x is less than 0. Oops, nope. When x is between 0 and 4. F of x is greater than 0 when x is between -2 and 3, and when x is greater than 5. F of x is less than 0 when x is less than -2 and x is between 3 and 5. So there's all my characteristics. I'm going to sketch a graph of a polynomial function that meets all these characteristics. Okay? Is everyone okay if I move on, or are we still writing these characteristics down? Okay. So once again, what do we treat f of x like? What do we treat f of x like? Our x values or our y values? Our y values, right? So we can read this as, these bottom two characteristics as, my y values are greater than 0, and my y values are less than 0 when so on and so forth. Okay? So keep that in mind. Can I go ahead and go on to the graph? So I'm going to be kind of sketching this as I'm looking at each characteristic, but my graph might change as I get to the next characteristic, because I want it to meet all my characteristics at the same time. Does that make sense? So for my very first characteristic, it's going to look different until I get down to my very bottom characteristic. Okay? So my function f is increasing when x is less than 0. On my graph, which part of the graph are the x values less than 0? To the left of my y-axis, correct? Because that's all the negative x values. So when x is less than 0, I want my function to be increasing, right? All the way up until it gets to 0. Once it hits 0, it's changing from increasing to decreasing between 0 and 4, correct? Here's 0. Here's 4. So between 0 and 4, it needs to be decreasing, correct? And then once it hits 4, it's going back to increasing. Does everyone see that? So once it hits 4, it goes back to increasing. So here's a rough sketch of my graph. Okay? That's going to change because I've got more characteristics than these first two. But so far, it's meeting these first two characteristics, correct? It's increasing when x is less than 0, decreasing between 0 and 4, and increasing when x is greater than 4. Does everyone see that? Everyone see those changes in direction at the certain pivot points? Let's look at our third characteristic. F of x, what do we treat f of x like? Y. So our y values are greater than 0 when x is between 2 and 3, and when x is greater than 5. So my y values need to be greater than 0, aka my graph needs to be above 0 between -2 and 3. So I'm going to erase these points here. So here's -2, and here's 3, correct? So my graph needs to be above my x-axis between those 2 points. Does that make sense? While still meeting these top 2 conditions. So like I said, I'm going to have to erase my graph a little bit. So I'm just going to go ahead and erase it real quick. So between 2 and 3, I need it, or negative 2 and 3, I need it to be above my x-axis. I still need it to be increasing or decreasing between 0 and 4, right? So there's 0, it's decreasing at 0, all the way to 4. So my graph is above my 0 between negative 2 and 3, correct? I also need it to be above 0 when x is greater than 5. So here's 5. And I'm still keeping these top two characteristics in mind. Does everyone see that? Okay, so now I want my y values to be less than 0, aka my graph is below the y-axis, or the x-axis, when x is less than negative 2. So that'll just be down like that. And between 3 and 5. So between 3 and 5, I'm dipping below the x-axis. Where's my pivot point from going from decreasing to increasing? 4. So I need to make sure I'm decreasing all the way to 4, increasing after 4. So there would be my graph. Does everyone see that? It's like a puzzle. You're just trying to piece it together with each characteristic, still keeping the other characteristics in mind. So there would be my graph. Any questions there? Now I'm not done with example 5, because it says use the graph to describe the degree and leading coefficient of f. So my chart is going to come back into play. I need to see what my graph is doing, what the end behavior is, and then I can describe whether the degree is odd or even, whether the leading coefficient is positive or negative. So on my graph, let's start over here on the left. As x goes to negative infinity, as my x values are getting smaller, what's happening to my y values? They're going down to positive or negative infinity? Negative infinity. Does everyone see that? As my x values are getting bigger and going towards positive infinity, what's happening to my y values? It's going up to positive infinity. So I'm going to my little chart that describes my end behavior, and I'm looking for the one that matches these two end behaviors. So which one would that be? Bottom left or bottom right? Or top left or top right? Say what? Odd and positive. It's this top left box. Because these match what I wrote on the board, correct? As my x values are going to negative infinity, my y values are also going to negative infinity. As my x values go to positive infinity, my y values are also going to positive infinity. So I can say the degree of the polynomial is odd and the leading coefficient is positive. Does everyone see how we went about that? After we sketched our graph, we looked at the end behaviors, matched it up with our little chart, and described if the degree is odd and the leading coefficient is positive. Any questions there? Can I go ahead and move on? There's our assignment. It's about 8 problems total. Not too bad. due tomorrow evening on candles. January 22nd. We have some time to be working on it in class, so make sure you get this written down. I'm going to project the book page on the board. Does anyone have any last minute questions about the notes before I stop the recording?